students, welcome back to this video session. I remain Samuel. In this video session, we shall discuss an application of matrices, one of the applications of matrices under finite mathematics. And that application is what we call cryptology. This video will still be under the video playlist on matrices and determinants. Please, it is highly recommended that before you continue with this video, that you have viewed the videos on that playlist, matrices and determinants, especially the videos on the inverse of a matrix, and the multiplication of matrices. It is very important. One of the applications of matrices is in the field of cryptology. What is cryptology? Cryptology is the study of secret messages. Cryptology is the study or the science of secret messages. The study or science of secret messages. The messages are codes, texts. Messages, codes, texts. Why are we learning this? This is very important. In fact, in most wars, you use a cryptology. And the agency I'm talking about, the agency that snoops in everything that you do, snoops in on Americans, snoops in on other countries. NSA, that the agency, they use a lot of cryptology to snoop in. And the coding, with your, have you ever thought of when you want to log into your mails? There are some algorithms that uses coding to program those logins, and passwords, your credit cards, your debit cards. So secure business transactions. Cryptology is in all those areas. Now, you can also say that cryptology is the process of making and breaking messages or codes, texts, making and breaking secret messages, secret messages, codes, texts. We see breaking, writing and cracking, writing it and then cracking it, Enciphering and deciphering. Enciphering and deciphering. Enciphering and deciphering. Making and breaking, writing and cracking, enciphering and deciphering. Encoding and decoding. Encoding and decoding. All these processes is what we call cryptology. The science of encoding and decoding secret messages is known as cryptology. And you see the applications in a lot of fields. A good example is the NSA. And then it's used in the military to convey communications. It's used in the business fields, in the computer, in the IT sectors, you know, in the IT field. So a lot of fields use cryptology. Now, cryptology comprises what we call cryptography and cryptanalysis. Now, cryptography is the process of writing decoded messages, and cryptanalysis is the process of cracking it. Okay? Cryptography is a process of enciphering secret messages. And cryptanalysis is the process of deciphering secret messages, or encoding. You know, you can use any of these words. It's whether you say making and breaking, writing and cracking, enciphering and deciphering, encoding and decoding. It's the same thing. Now, there are many ways, many types of cryptology. There are many types of it. But in this video, we shall study the aspect of cryptology regarding the application of matrices, with regards to the application of matrices. That is what we shall study in this video. The application of matrices in crypto systems or in cryptology. We also have this in modular arithmetic and algorithms. That is under discrete mathematics. Yeah, discrete mathematics, you have modular arithmetic and algorithms. You also have this part of, you see the applications in cryptology as well. But in this video, we shall be concerned with just matrices under finite mathematics. When you talk of a cipher, you know, cipher and ciphering and deciphering. This was used by the famous people, early folks that used it a lot was the Persians. This is a system of secret messages based upon a key. Yeah, so it has a key to decipher the message or to decode the message. The application with matrices in matrix applications, we have the message, we have the coded message, and we have the encoding matrix. These are the two things that you have. Meanwhile, let me ask you this anyway. Besides the applications we mentioned, NSA, business field, IT field, a lot of us deal with secret stuff, right? If you know you don't have any secret, raise your hand if you don't have any secret. Come on now. Almost everybody has secrets. And there are some things that you want to, let's say maybe you don't want people to know about, right? NSA, please don't come and start snooping in on me now, because I am teaching this. Anyway, I don't care. Now, there are some things you don't want people to know about. So let's say you're in a classroom and you want to write something to another person, and you don't want a third party to see it. So the easiest way is you write a coded message and you put the encoding matrix to that message, and then you pass it to the other person. So let's say a third party gets it, right? If that person does not know matrices, or matrix inverse, then he or she will not be able to know the message. So human beings tend to use secret messages a lot. Human beings tend to use secret messages a lot. So if you know this, then you can easily maneuver somebody who does not know the matrices. So this is a good aspect that you will at least find interesting in matrices. Even if you've not found other things interesting, you should find this one interesting. Now, let's get back to this, okay? You have the encoded message and you have the encoding matrix. There are two things that the encoding matrix should have, at least. The encoding matrix, note, the encoding matrix should, number one, be invertible. You know what I mean by invertible matrix? A matrix that has an inverse. It should be a matrix that has an inverse. A matrix that has an inverse. That is number one. Number two, the elements of the matrix should have positive integers as elements. So the encoding matrix should have an inverse, and then it should have positive integers as elements. Once these conditions are satisfied, then you can now code your message and then use the encoding matrix to decode the message. We are going to solve an example right away. So let's form something. Let's form a scenario, right? Let's form a scenario. So the mom said, Sam, what did you learn in church today? What did you learn in church today? Let's say I went to church and I came back and my mom said, what did you learn in church today? Sam, Mom, the priest said something very important. Here is the basic message. Here is the basic message. So you come and you give your mom the message. You just write 1, 2, 4, 48, 47, 16, 55, 22, 80, 29, 28. Here is the basic message, and the encoding matrix, is 5, 2, 3, 1. So if let's say you have a son and you sent him to church, and he came back and he said that this is the message that the pastor, that the priest said in church, the basic message, and he gave you the encoded matrix, what are you going to do to your son? What are you going to do to your son? You will say that, hey, you're a mischievous boy, right? That is if you don't know matrices. But guess what? If you knew matrices, then you should go ahead and solve it. You should go ahead and find the message. That that is what we are going to do tonight, finding the message. So let's look at how we will decode this message here. We are given the encoding matrix. So the first thing you do is this. You're given the encoding matrix, and then usually you will also be given the cipher or the key. You will also be given the key or the cipher. And the key, here we are using letters of the alphabet. We're going to use the letters of the alphabet here. English letters, which is 26. Now, if you speak Spanish, you use the letters of Spanish. If it is my language, the Igbo language, we have 36 letters of the alphabet. So, if I want to make it complicated, I use 36 letters of the alphabet. If you speak Russian, you use Russian alphabet. So, whichever language you speak, you want to make it more complicated, you use that language. Now, you are going to use we will use the English letters here, because that is one you're all familiar with. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. And here, this is 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and then 26. Some people will also add more keys. 0, they can say the blank, space or blank to be 0. You can say 0 or 27 if you want to. When you want a space in the message, you put 0 or 27. And then if you want a question mark, this will be 28. If you want an exclamation mark, this is 29. And it depends on what you want in the key. You can put several punctuation marks in the key to make it more complicated for someone to decode. So, you're given this message. You're given the encoding matrix, and you're given the key. Sometimes you're not given the key. The person sending the message assumes you have the key already. Sometimes, in this video, we assume that you know the key, which is the English letters of the alphabet. And then this is additional information. Now, what we want to do is this. You look at the message. You don't know what 124 is not here. So there's no 124 or 48 or 47. Because they gave you the encoding matrix, that tells you, hey, this has got something to do with matrices. Once they put the encoding matrix, that is a hint that this will have something to do with matrices. You now ask yourself, what type of matrix is this? The encoding matrix we use is usually a square matrix. Remember, if it is going to have an inverse, that means it must be a square matrix. And what is a square matrix? We talked about it. It is a matrix with an equal number of rows and columns. That's why I recommended you view the videos in the playlist on matrices and determinants. So, what kind of a square matrix is this? You only have 4 elements. right? So you just say, okay, let this be A. Let A be this. Let matrix A be, because it is only 4 elements, it is a 2 by 2 matrix. This is now 5, 2, 3, 1. 5, 2, 3, 1. Remember, the encoding matrix must have an inverse. And how do we know it has an inverse? What is the determinant? 5 minus 6, which is minus 1. So that means the determinant is not 0, so it has an inverse. It is invertible. And also, it has only positive integers as the elements. So the first thing you want to do is this. You want to find what type of matrix is the encoding matrix. You put it here. It is a 2 by 2 matrix. Then you now put you put the message in matrix form. Let A be this, and then let B be. Since your encoding matrix is a 2 by 2 matrix, since it's a 2 by 2 matrix, that B be, let matrix B be the coded matrix. The coded matrix of message. The coded message. So B, so this is 2 by 2, you arrange it. This is 1, 2, 4, 48, 47, 16, 55, 22, 80, 29, 28. This is your coded message. So it's a what? 2 by what? 2 by 1, 2, 3, 4, 5. 2 by 5 matrix. The next thing you do is this. You come and the first step, find the type of square matrix that the encoding matrix is. Second step, put the coded message in the type of, in the same number of rows. Because if this is a 2 by 2 matrix, you make the coded message that it should have also 2 rows. Right? Then the third step is to find the inverse of this matrix, A inverse. So let's find the A inverse. Third step. You find A inverse. Find A inverse. So we talked about, we've done inverse of a matrix. Let's go ahead and find that. Let's use the row reduction method. Let's use the row reduction method because it's pretty much easier for us and faster. So if we use row reduction method, 5, 2, 3, 1, put this in augmented form, 1, 0, 0, 1. This will be 5 and 2 minus 2 arrow 1 plus 5 arrow 2. And if we have that, this will be 5, 3, 1, 0. And this is minus 10 plus 10 is 0, minus 6. Minus 6 plus 5 is minus 1. Minus 2 plus 0 is minus 2. And 0 plus 5 times 1, 5. Then you have another operation here. Have another operation here. 3 and negative 1. So this will be 3R2 plus R1. This is 0, negative 1, negative 2, 5. And this will be 3 times 0, 0 plus 5 is 5. 3 times negative 1, negative 3 plus 3, 0. 3 times negative 2, negative 6 plus 3, negative 6 plus 1, negative 5. 3 times 5, 15 plus 0, 15. Right? Please, we have done this, we've done this in previous videos, so view it. This is the R1 divided by 5. and then negative root 2. So what we got now is 1, 0, negative 1, 3, negative 1 and 3. Then we have a 0, 1, 2, and negative 5. So our A inverse, what is our A inverse? Our A inverse is negative 1, 2, 3, and negative 5. That is our A inverse. Fourth step, you now have to find A inverse times B. You see, that's the joy of it now. You first of all have to find the inverse of the encoding matrix. And once you find the inverse, you see now, that is matrices. You have to know the inverse of the matrix. Then you now multiply, you now find A inverse times B. A inverse times matrix B. That's what you find. So you also have to know multiplication of matrices. Now this will now be what now? Let's get this. This is negative 1, 2, 3, negative 5 times 1, 2, 4, 48, 47, 16, 55, 22, 80, 29, 28. So we did a multiplication of matrices. First of all, let's see whether they are conformable for multiplication. This is a 2 by 2, and this is a what? 2 by 5. So this is equal to this. So the product will be what? A 2 by 5. The product will be a 2 by 5 matrix. I don't want to erase this key. So I'm going to come back here. I'm not going to erase this key. Now this is A inverse. This is a B. Now A inverse B. This will be a 2 by 5. And this A inverse B is going to give us the message. Okay? This is the message. That is the nice thing about it. It's the message when you now find message when combined with the key. You know, message used with the key is the message that when you have now used the key to decode it. So let's go ahead and multiply that. When we multiply that, we have row by column, negative 1 times 124 plus 3 times 48. And then we have negative 1 times 47 plus 3 times 16. Then we have negative 1 times 55 plus 3 times 22. Then we have we have to get more space here. Then we have negative 1 times 80 plus 3 times 29. Then we have negative 1 times 20 plus 3 times 8. Right? Then the second one, we have a 2 times 24, 2 times 124, row by column, plus negative 5 times 48. Then we have a 2 times 47, plus negative 5 times 16. Then we have 2 times 55, plus negative 5 times 22. Then we have 2 times 80, plus negative 5 times 29. Then we have 2 times 20 plus negative 5 times 8. Negative 1 times 124 is negative 124 plus 3 times 8 is 24, 4, 2, 3 times 4, 12 plus 2, 14, 144. Then this is negative 47 plus 48. This is a negative 55 plus 66. This is a negative 80 plus negative 80 plus 3 times 9, 27, 7, 2, 3 times 2, 6 plus 2, 8, negative 80 plus 7, and then what we got here, so that we can close this here, negative 20 plus 24, right? Negative 20 plus 24. Then here we have a 2 times 4, 8, 2 times 12, 24, 248 minus, plus minus is, minus 5 times 8, 40, 0, 4, 5 times 4, 20 plus 4, 24, right? 2 times 7, 14, 4, 1, 2 times 4, 8, plus 1, 9, right? 2 times 7, 14, 4, 1, 2 times 4, 8 plus 1, 9, minus 5 times 16 is 80, 80. Then we have 2 times 55, that should give us 5, 10, 1, 10, 11, 110 minus 5 times 22 is still 110. 2 times 80 is 160 minus 5 times 9, 45, 4, 5 times 2, 10, plus 4, 14. 5 times 9, 45, 5, 4, 10, plus 4, 14. Then 2 times 20 is 40 minus 40. Alright, folks, what we got now? We have a 144 minus 124 is 0, 20. 20, right? This is 1. 66 minus 55 is 11. 87 minus 80 is 7. 24 minus 20 is 4. And then we have a 248 minus 240 is 8. 94 minus 80 is what? 14. Right? This is 0. 110 minus 110 is 0. 160 minus 145. 10 minus 5 is 5. Right? And 5 minus 4 is 1. 15 and 40 minus 40 is what? 0. Alright, so this is actually the message here. This is a 2 by 5. Right? Now what do we do now? We have to what? Spread it out. We have to spread this out. We have to spread it out now. We spread it out. Let's spread it out here. Let's spread this out here. So this gives us what? 28, 1, 14, 11, 0, 7, 15, 4, 0. Right? So let us see what the priest said. His message to Sam. 20 is what? We go here, T, uppercase T. 8 is H. H. 1 is A. Wish I had a colored chalk. I would have used the colored chalk here. H. 14 is N. 11 is K. 0 is space. Space or blank. Space. So you leave space here. 7 is G. 15 is O. 4 is D. And you can put this 0 as dot. If you want, you can also put 0 as a dot. I mean, punctuation mark. You can put it as dot. If you want to also put it, it could be dot or space of land. Just know your key and just make sure that the other person that will decode it also has the key. If he or she does not have the key. Alright, this is part 1. Thank God. See you in part 2 on You Got the Good.